Hello, good morning, good afternoon, and good evening to our webinar today. Before we start, we will give people the chance to join. It's just 6 o'clock, and we will start in roughly 1 to 2 minutes, and then we will be back. All right, good morning, everyone. So I still see many folks coming into this webinar. We are excited to introduce and announce this distributed testing in our webinar today, the intro to distributed testing. Before we start, I have a few housekeeping matters that I would like to present. We have around 60 minutes of content with remaining time for questions. So whenever you have a question during the webinar, let us know via the GoToWebinar control panel on the right-hand side of your screen, and we will take care of the questions after we finish the presentation. If you have to drop off during the webinar, we will send a recording after the webinar within a couple of days, so it needs a little bit of time to process the video. And if you are having a hard time to see the terminal or you cannot read the presentation, there's a Zoom button on the top of the presenter screen that you should see from GoToWebinar. And leave us your feedback in the feedback survey when you leave the webinar. That would be very well appreciated. We'd like to continuously improve our webinars. And now let's do a quick sound check. So if you can hear us, let us know from where you're joining today in the question box. And while we look forward to your answers, I can already hand it over to you, Mark and Benedict, for today's presentation.
Yeah, hi and welcome to our webinar. We're excited to show distributed testing today. This webinar is going to be about distributed testing and help you speed up slow tests to get faster feedback in your builds. So this is us. I'm the guy on the right. My name is Mark Philipp. I work as a software engineer here at Gradle. I'm also quite active in open source and in testing in particular. So I'm the JNet team lead and have been working on test automation and improving that for a long time now. With me today is my friend and colleague Benedict, Benedict, you want to introduce yourself quickly maybe?
Sure. Hey, my name is Benedict. I'm also a software engineer at Gradle, working on test distribution, and I also work on the Apache Commons project as a maintainer for several years now. So if you've used the Apache Commons Lang library or Commons IO, you probably came along my work already.
Thanks. Yeah, the two of us, of course, with additional people, have been working on test distribution for quite some time now, and yeah, we're really happy to share that with you today. This is the agenda. First, I'm going to briefly discuss why fast feedback from tests is really, really important for your builds and for your productive flow. we're going to take a look at some existing solutions for speeding up test execution. And then we're ready to introduce distributed testing in Gradle Enterprise. We're going to first do an overview, explain how it works in general, and then we're going to take a deep dive and take a look at how does it look, how does it work from a developer's point of view, what do you have to do in your builds to use it. After that's done, we're also going to take a different angle and going to take a look from an operations perspective. How do we deploy these agents? What do we need to know about security and so forth? Last but not least, of course, we will summarize the key features of distributed testing in Gradle Enterprise, and we will discuss next steps. So first off, why fast feedback from tests is absolutely crucial and important. Of course, there are various reasons why tests are slow in the first place. The simplest being you just have lots of integration and functional tests, and that might be a good thing, right? You want to have a good security net in your development, iterate on your software and add new features to it. So they might really, really all be valuable, and you want to have them to give you confidence when you make changes that things are still running, when you add new tests, that your new features are working correctly. You might be running them sequentially. That makes them slow. So usually it's a good idea to think about running tests in parallel. You might be generating a huge number of tests to cover a wide range of inputs, which is absolutely a valid use case for testing, but sometimes that can generate lots of tests, and if those are slow, then you might be in trouble. Another reason for tests being slow might be recreating expensive objects. For example, if you have a Spring application, then you might be creating or recreating application contexts for each test, and that can take some time and can make tests slow. Another reason might be that tests depend on some external service that is slow or slower than if it would just be unit test. For example, if you have a database that you need to connect to or some external web service, that usually makes tests slower than just bare unit tests. You might have end-to-end tests or system tests implemented via browser automation like Selenium or WebDriver. Those tend to be slower than just unit tests. And all these tests are valuable. They provide you with confidence to release software. So we want to keep them, but how can we get out of this situation that this is slowing us down? The place we want to be in really is that feedback is instant or as quick as possible. And I think most of us remember this feeling when we started programming. Yeah, we just change something, try it out, and get instant feedback if it works or not. And that's kind of the thing we want to feel as developers every day when we work on software. We want this to be fun and we want to be productive. Of course, it's more than just happy developers, right? It's not just a feeling, it's also being productive. And that is absolutely important to your productivity, that you have fast feedback cycles. And the less context switching you need to do, the less you basically impact your creative process. So think about, you push a change to CI and you have to wait for, I don't know, 30 minutes for the build to run, and only then you will get feedback, right? What do you do in those 30 minutes? Well, you start on something else, you read emails, you get distracted, and then once that build is finally finished, you can go back and look at the feedback and see what you might missed, right? What you have to change again, and that takes a lot of effort. You want to have this focus of working on one thing, getting it done, and then moving on to the next. And also, if feedback cycles are not as fast, you cannot build as often. It affects your behavior really, and building less often makes it difficult later to debug if you have an issue, because the change sets then have accumulated already, and the cause might not be clear. It's harder to find out what actually caused this breakage. And faster feedback cycles also make for higher quality software, because the chance of a defect passing through the quality gates, it's much less. And the smaller the change sets developers can make, the better, because it's also much easier to spot a bug when you do a code review if the change set is small. And if change sets don't get stale and accumulate, it will be much less likely that you introduce a bug, for example, just by resolving a merge conflict. So fast feedback cycles are absolutely important. And last but not least, we've seen some companies that are really tempted to turn off tests, so not all of them maybe, but some of them, and other safety measures in order to ship faster. And that usually doesn't pay off in the long run, right? That might be something you do once, but then, yeah, you want to keep these tests, they're valuable. You just want to run them faster to keep the feedback cycles short. That's basically what we strive for. And this is not just a feeling, you can also quantify the cost of feedback cycle time. So let's assume you have a team that runs 10,000 builds per week, which is a typical number for a 100 developer engineering team. And every minute of test time causes 5 engineering years of wait time per year. So the exact calculation is in the bottom, right? You have 10,000 waiting minutes per week, basically. And if you spread that out over 220 workdays, you end up with 5 engineering years just for waiting. If you would just wait, right? You usually don't, right? You don't sit around and do nothing, but instead you have context switching, you start on something else, and all the problems that I just iterated on the previous slide will then occur. So really, the bottom line here is you should try to quantify these costs of your feedback cycle time, and that's really all that matters to productivity. Gradle Enterprise addresses 5 primary pain points, and the one we're talking about today is the first one. It's the idle wait time here. So we want to have fast feedback cycles, and we want to be productive. So the build and test accelerator so far that we provide in Gradle Enterprise consists mainly of the build cache. If you're familiar with the build cache, yeah, you can really speed up your builds by up to 90% for Maven and for Gradle. And today we're going to put that distributed testing on top of that to give you even more speed up in your builds to achieve faster feedback cycles. Before we do that, we're going to take a look at some existing solutions for speeding up test execution. The first one I briefly mentioned is build caching. So build caching is a feature of Gradle Enterprise. There's a remote cache built into Gradle Enterprise that you can use for Gradle and for Maven builds. Basically what it gives you, it allows you to cache the execution of a Gradle task or a Maven goal. So if the inputs of the Gradle task or Maven goal haven't changed and it has been run before, you can upload the outputs from the cache and you don't have to execute it again. So you save a lot of time. And that applies to any task. So it could be a compile task, for example, but it could also be a test task. The thing with test tasks and caching, you don't have to run the test task if nothing has changed, right? If all your code is still the same, yeah, no reason to rerun the test task. But usually you do make changes. What happened now? Okay, sorry. Yeah, so now we're back on the presentation. Yep, we are. So usually you do make changes to your code, right? That's why you develop software in the first place. So you end up having different inputs for your test task. And then that means you have to rerun the test task in that case. So build caching only has a limited benefit for testing in that sense, especially if you have lots of integration tests that basically depend on the whole system that you develop, and then you have to rerun them every time you make a change to your code. Another existing solution is called single machine parallelism, and that's a built-in feature in Gradle. It's controlled by a couple of flags, so you can enable with -- parallel project parallelism. That means that tasks in different subprojects in a multi-project build will run in parallel. By default, it's off. It's usually good that can significantly speed up your build, not just your tests. Another flag is max workers. In addition to parallel, it controls like the maximum number of parallelism that you can achieve on a machine, and it defaults to the number of processors or cores on your machine. So say you have an 8-core machine and you enable -- parallel, then up to 8 tasks can run in parallel. When it comes to testing, there's another very important flag on the test task itself. It's called max parallel forks, and it controls how many VMs are used to run your tests. So this could be just one, which is the default, But if you increase this, for example, you say you have, I don't know, you want to run 4 VMs in parallel, you can set it to 4, and then 4 test classes will be run in parallel. It's also restricted by the max workers flag. That's why it's also listed here. So if you only have, say, 8 cores, you should not run more than 8 VMs in parallel of tests, right? So that's kind of where that comes into play. Another solution is called CI fan-out. And here, test execution is distributed by manually partitioning the test set and then running the partitions in parallel on several CI nodes. So it usually looks like this. This is a pseudo pipeline script. So you have some stage, it's called compile, where you compile all your test classes or your production classes as well. And if you have a build cache, you can store that in the build cache. So later stages don't have to redo those steps. And then in the next stage, which you can run in parallel, you will have different groups of tests running, which in this case are modeled as Gradle tasks. Could also be includes, excludes, something like that, right? And those stages would be allowed to run in parallel on different CI agents. So let's assess these existing solutions. Build caching is great in many cases, but as I said previously, it doesn't help you when the test inputs have changed. So especially for test tasks that can dominate the build time, build caching is not always the solution. It might still help for the compile tasks and other tasks that are really intense in time, but it doesn't help for tests if you have to rerun them. You have to run them, you have to pay the price. Single machine parallelism is limited by the machine's resources the build runs on, right? You cannot scale beyond your cores. CI fan-out does not help at all during local development. It only works on CI. And it's really inefficient, in particular on ephemeral CI agents. So those are agents you start up for every build. You will have to probably download the Gradle distribution again, download all the dependencies again, maybe build everything, especially if you don't use the build cache, up to the point where you can actually start executing the tests. There's a lot of work that has to be done on each of these nodes that you fan out. And also it requires manual setup. So you have to think about this pipeline. You have to configure it on your build server. You have to think about test partitioning. How do we split the tests into equal groups? And also result collection and aggregation is something you have to worry about. So we would like to ask you the first poll of today. Which strategies to speed up test execution do you already use? Let me send that poll to you. Yep, you should now see it. I'm going to keep it open for maybe up to a minute. Let's see, 70% voted now.
If you like, we can take the time to answer one of the questions that have already come in. Somebody asked, what are the inputs and outputs of the test task? Okay, yeah, I was going to explain it later a bit, but yeah, the inputs of a test task are usually the test classes, the jars on the class path, some configuration options, but that's the main inputs. So basically what has influence on this test task. And inputs outputs is a Gradle concept. So if you're familiar with Gradle, you know that concept. But yeah, I mean, I'm going to come back to that later when we introduce distributed testing. Okay, I think we have 85% voted. So let's close the poll. And share the results. There we are. So 62% of you use build caching. That's great, cool, good to know. About 60% use single machine parallelism, so just parallel or max parallel forks probably. And about a third use CI fan-out already, so that's interesting. So this seems to be a true problem for some of you. So and you have actually taken steps to address that. And the people who voted other, please comment
yes,
what strategies you use.
All right, thanks for the answers. Now that we know that, we know about existing solutions, we can introduce our solution and then later compare it to the existing solutions. So the idea of test distribution in Gradle Enterprise is to extend the test parallelism by fanning out test execution to remote executors, and then letting the build tool coordinate partitioning of the test set and collection of results. So let me explain that picture below. On the left, we have a Gradle project that is checked out to a developer or CI workspace. On the right, we have Gradle Enterprise, which is an on-premise server application, and we have a couple of agents connected to it. So now we want to run tests. So the first step for that is we have to discover the test set, which is the set of test classes we want to execute. Once we've done that, we can request agents from Gradle Enterprise, and Gradle Enterprise will estimate the number of agents we are likely to get and send the number back to the build, which will use it to partition the test set into chunks and then start test execution. These agents then get assigned to the build by Gradle Enterprise and request test inputs from the build. So here we have the inputs again that have come up before. So the inputs are, for example, test classes, the jar files on the test class path, or any additional inputs that the tests read. They have to be transferred to the agents to replicate the workspace that the build runs in to a certain extent, to that extent that the tests need. Once that is done, the inputs are sent from the build to the agents, and also the partitions are sent to the agents that they are supposed to execute. So like which test classes should run on which agent. The agents then cache the inputs. So next time they run maybe the same project or a different project, they wouldn't have to request all the resources again. For example, think about the test runtime class path. You might have JUnit on there, for example, and usually you don't upgrade JUnit with every build, so you can reuse the same jar file the next time. And also you only have to transfer those tests that you need that have changed. Once that is cached, execution of the test is started on each agent that is assigned. And as tests are executed, results are continuously reported back to the build. And in the very end, the outputs of the tests are also transferred back. So this might be additional output files that the test classes write, or some additional reporting, or for example, if you use a code coverage tool like Jacoco, it might be the coverage data that is basically recorded while the tests are executed. So those outputs are sent back automatically to the build and then merged and stored by the build, in this case our plugin, in the workspace in the usual location as if tests had been executed locally. So that's the overall flow. And we will support both Gradle and Maven for this. Gradle is coming first. So in April next month, we will release it for Gradle first, and then Maven support will come in the next release. So it's already planned. These are the current estimates when you can kind of use it. So as I said, Gradle in April, the Maven support will probably come in June. Maybe if we're faster than that, of course, earlier. So we won't wait for June if you have it ready. So we will support Maven and Gradle as we already do for build scans and the build cache. Yeah, now it's time to take a closer look from a developer's point of view. How does it actually work? How do I have to change my build? And for that, I would like to pass it on to Benedict, who has prepared a demo and will show that to you.
Yeah, sure. Let me try to get control. This should be the right thing. All right, so we prepared a little demo for you. And at the very first, I would like to start a Gradle build on this project. Just a second. All right. What? Sorry about that. Probably a typo. We're on tasks. Okay, now we're going. And as this build is executing, I'd like to show you around in the project a little bit. As you can see, I've opened the build script already, and we are using JUnit Jupyter. I saw there was a question which test frameworks will be supported by distributed testing, and we have a slide for that later. For now, I'm using JUnit 5 in this project. This project is actually a generated project that we use at Gradle to test the performance of the Gradle build tool itself. So it has some artificial classes that have a set of properties. They all look the same. It has 100 classes and they all have some properties. What is more important for the testing and distributed testing webinar is how the tests look like. And we have a matching test for each production class. So we have 100 production classes that makes for 100 test classes. Each test has 10 test methods, summing up to 1000 tests that are executed. And each test sleeps for 100 milliseconds. So they are fairly equally distributed regarding their runtime, which might not be the case for every project, but it makes the demo a little bit more reproducible. So as you can see, Gradle is having a hard time working through all the tests because I have to execute 1000 tests now that all have this sleep. And we'll give it some time to finish with that. And while it's burning through the tests, we can see that the build time of this build was actually 1 minute and 47 seconds. And I guess that's something that's kind of what people experience in their day-to-day workflow. It's like a 2-minute build. Yeah, let's just build this and wait until it's finished. But it was already quite some time during this this presentation, right? So what can we do about it? As Mark explained, the first thing, the most easiest thing is to increase the single machine parallelism. And we have this flag on the test task, or this configuration on the test task called max parallel forks. And the default setting for that is 1, meaning that I just use one VM fork and all tests are executed sequentially. And I've now set it to 2, and we can see the effect by rerunning this build. And what we will see is that that this already dramatically speeds up the build. So I have a pretty beefy machine. I could theoretically run more forks in parallel, but for the sake of the demo, let's assume that 2 is all my machine can handle. And it really depends on your tests and what they are doing. If they have to spin up, I don't know, some Docker containers because you're using test containers or something like that, that might be all your machine can handle at once. And as you can see, we already executed 600 tests and we are at about 30 seconds. So it seems to be faster already. And we should land by somewhere at 55 seconds or something like that. But still a long time waiting for test execution. And here we go. We have finished executing tests, this time in 55 seconds. So that's already pretty good, better than before. But if this is all my machine can do, what do I do if I want to speed it up even more? Well, this is where test distribution comes into play. And to activate that on the build, I just have to apply the distributed testing plugin. And what this will do, it will create a new extension on the test task. And to make that available in IntelliJ, I need to do this little IntelliJ dance that recreates the model. And after I've done that, I can configure my test distribution. So I have this new configuration object here on the test task. And what I need to do is I need to enable it explicitly because we decided that you have to explicitly opt into distributed testing, because your tests, they have to be kind of self-contained. So you can't have, for example, a task that's running before the test task that spins up a database for you, simply because that wouldn't be executed on the agents. So let's see what happens now if I run again with test distribution enabled. And this actually now connects to our distributed testing infrastructure on AWS. We have 12 agents deployed to our Kubernetes cluster. And as you can see, it speeds up the build dramatically. So we started with 1 minute 47, I think, and now we are down to 14 seconds. Imagine what this would mean for your productivity on a day-to-day basis. Also, we can see there was a link created. This is actually a build scan link. If you did not have a chance to let me quickly go to my browser and open that. So build scans are a feature actually of Gradle Enterprise. And if you did not have a chance yet to look into that, we have some webinars and some content available that give a good intro into what Gradle Enterprise can do. For now, all I want to say about it is that it has like a record of what happened during the build. And we will go back and forth between IntelliJ and the build scan to observe various things. So the build scan also collects some data about distributed test execution. And as you can see here, I have the name of the test task that I executed. It's called :test because it's the default test task. And this build got assigned 14 executors. And this is the sum of the 2 local executors that I configured before by setting the max parallel fork setting. And it got assigned 12 remote executors. So if you use distributed testing, it will never be slower than executing on your machine, because your machine will start executing using the local executors already. And after some time, as Mark explained, the agents that are assigned to the build become available, and we can actually see how long that took from beginning of test execution until they reported that they are ready to start executing test petitions. So it was about 300 to 500 milliseconds for each of the agents. We also record some of the file stats, for example, how many files we needed to transfer and how much bytes that were in sum. In this case, because I did this before the webinar already, I did not have to transfer any files because they were cached. All right, so let's talk about test reporting. What happens there if we use test distribution? And you might know that there is also some configuration on the test task that you can use to increase the logging. And I've just configured it here to output in the console view the passed, failed, and skipped events. So whenever a test fails, passed, or skips, it will be logged into the log, because usually the test task doesn't log anything at all. It just executes and is done. This little display granularity thing is to output the maximum detail. And if we run the tests again, then we will see that the executors start reporting. You can see, I don't know if it's visible in the recording or in the webinar, but the local executor reported some events here, and here we can see, for example, that we have the partition 7 that was executed on some agent. This is a name that was generated by our Kubernetes cluster, and we see that this test actually passed. We also get a test report. So if I open the test report, I have to move it to the other screen. Give me a second. So it's just the usual test report that you know from Gradle. It looks completely the same. Everything, no matter where it was executed, is collected here in the report. And there's one little thing. If I go into one test, I can navigate to the output and I see where it actually was executed. We generate an artificial output event for you so that you can see where this was executed. So this test actually ran on my local machine, so it was executed on the local executor running on localhost. All right, let me find IntelliJ again. So you might wonder what happens if a test fails, and I also want to show you that. So let's just make this one test fail by using the fail method of JUnit. And I know that the partitioning will cause this test to be executed on one of the remote executors. So let me rerun this again, and we would expect the test to fail. And we give it some time to execute those tests. And you can see already that one test failed. And if we head back to the build scan of this build, we can go to the tests view that basically shows you all the tests. And if we go to the failed one and navigate to that, again, we can see this artificial output event that helps us identify the potential problem. Is there something wrong with the agent, or was it the test? So this gives you some way to analyze what's going on there. All right. Let's talk some more about test outputs. For that, I will remove this failure again and head back to the build script. One common output that you have when you execute tests is test coverage reports. So in Gradle, there is a Jacopo plugin, for example, that will generate a report for you. And as Mark explained before, if you're using the CI fanout strategy where you partition your tests by hand, you have the problem that you have several Jacopo reports that you somehow need to merge together again at the end. Luckily, in test distribution, we did this for you already. So if I run this build again, then what will happen is that test distribution will transfer the Jacopo agent to all the test agents and attach it to the test VM that's running on those agents. And the Jacopo metrics are collected at the end of the build and sent back and merged together. So if I now go to my reports again, sorry, I forgot to actually run Jacopo, my bad. This is the run we want to do, because the Jacopo plugin actually only generates Jacopo metrics during the test run, but to generate the HTML report, there is an additional task that has to be run after. And that's what I did here. And now I should be able to open the Jacopo report. And that's again on the other screen. Let me show it to you. And as you can see, I have a Jacopo report that has 100% test coverage. And I don't know if you remembered it, but the test project had 4 packages called P1 to P4. And as you can see, we have the test coverage metrics, even for those tests that ran on the distributed test infrastructure. Okay. So the last thing I want to show is this issue with tests that need a special environment to run. So for example, you might have tests that require a dedicated or special JDK. So you want to do some cross JDK version testing, or you need a database to be available on that machine. Or maybe you have some tests that you want to run on a particular operating system because you have this cross operating system problems with file path and line endings. And so you have some tests that only execute, for example, on Linux or only execute on Windows. And I really want to show you that, how we support that. So I have this base test in the P4 package that all the other tests inherit from. So whatever configuration I apply to this base test will be applied to all the other tests. And I also prepared the Linux only annotation which is a composed JUnit 5 annotation that tags all the tests with a particular tag and enables them to be run only on Linux operating system. So as you could imagine, if I run this test now, they would be skipped on my machine because I'm using macOS and not Linux. So what can we do about that? So the first idea that I have is we should partition our tests into a test task that only executes the tests that don't have any requirements, and one task that has this special Linux testing. So let's do this. I will add a filter here on the default test task, and I'll use the exclude tags filter facility and define it with Linux. So this will cause the default test task to skip all the tests that I marked with Linux only. So let's go ahead and create another test task that executes the Linux tests. So I'm creating this test Linux task. And then what I want to do is the opposite of this exclude. Here, I want to include only the things that are tagged with Linux. So now the test Linux task will only execute those tests. So if I run that now, that will skip basically all the tests because they are marked as being skipped on macOS. So that doesn't make a lot of sense to do on my machine. But actually, I didn't run it because it came from the cache, as you can see. So I should maybe rerun tasks again, that you can see that they are all skipped. Yeah, that was pretty fast. But we can go to the build scan and see that they were all skipped. I'm doing that right now. So all the 200 tests were skipped, and that makes sense because I'm using macOS, as I said before. So let's make sure this is running distributed and that this is only running on agents that have macOS Linux running. Sorry about that. So again, we want to configure test distribution, and we want to set it to enabled again. And then we have this requirements API that you can use, and it's basically a string-based API where you can define the requirements that your test task has. So let me set OS equals Linux, and the agents, when they start up, they do some detection of the environment they are running it in. So they will set a tag for, or they will set a capability basically saying which OS they have. So our agents are all running on Linux, so all the agents will match this requirement. We also detect the Java version that they are running with. So there's also a Java capability on the agents that you can use. And as Mark will show later, there are some ways for administrators to add custom capabilities to agents. Okay, so I now have this filter in place and I have the requirements configured. If I run it again, then this should be distributed to our distributed test infrastructure. But as you can see in the console view, 20 tests were skipped again. So why is that? Of course, it's because I'm still using the local executor here. I haven't deactivated it. I just said this test task should run distributed, but I didn't say anything about my local machine. So we should fix that, but we want to make sure that, for example, my colleague Daniel is still able to use his local executor because he is running on Linux. He's developing on a Linux machine, so he might want to use his local executors. Or if this build is executed on CI, that CI agent might also want to use the local executor if that CI agent is running on Linux. So let us just add some logic here. And I'm using system utils from Apache Commons Lang. That's pretty handy for things like this. There is a constant defined on that class called isOSLinux, and I'm saying, okay, if I'm not on Linux, so if I'm on macOS, for example, I don't want to use local executors at all. So I set it to 0. And if I run this test task again now, we will see that all the tests are executed. And here we go. We can have a look at the build scan and observe that all tests were executed. So 200 tests passed. And if we go back to the custom values that I showed before, you can now see that 0 local executors were used, but 12 remote executors were used. And this is a really, really powerful feature. Think about it. You can run tests from your local machine. You can start tests on a different operating system. So you don't have to go through all the loops by committing something to Git and then pushing it and then creating a pull request and then starting something on CI and then waiting until it's executed. You just do it from your local machine. You don't have to do this context switch. You just have this, basically this interface that Gradle provides to you. And to make this complete, you would usually want to define a dependency between the check task and the test Linux task, so that test Linux is always run. And now if I say Gradle build again, this will make sure that the test task is executed and the test Linux task is also executed. As you might know, Gradle executes tasks inside a project sequentially. So it will first execute the default test task, and there is a test Linux task that will be executed on the remote testing infrastructure again. And that is all I wanted to show for the demo. And with that, I'm giving it back to Mark.
Thanks, Benedict. So let me change the presenter here. Yes. All right. So much for the demo for now. I'm going to now explain a few more things in a bit more detail and recap them. So first off, the configuration that you need to apply the test distribution plugin. So this assumes you're already on Gradle 6, but as I will show later, it also works on Gradle 5. You would, in a Gradle 6 build, have the Gradle Enterprise plugin as a settings plugin, and then also configured your Gradle Enterprise server in the settings script here. And then in your build script, you would apply the test distribution plugin, as Benedict has shown in the first build. And of course, version 1.0 is not yet released, but we are still working on that and will do so soon. In the test task, you have then to use the distribution extension of the task and then enable test distribution basically. And you have to use the JNet platform for that to work. There are a few configuration options for the test distribution plugin. So first off, you have to opt in into test distribution. As Benedict said, that's because you first need to make sure that your tests are actually self-contained. So anything that you need to start up before your tests are running, you have to do inside your test execution kind of. So there are like lifecycle listeners for JUnit that will help you do that. If you currently use a Gradle task, for example, to start a server or tear it down afterwards, that will not work for distributed execution. Then you have the possibility to restrict the number of local and remote executors. So by default, max local executors is equal to the max parallel forks count that I've shown earlier. So if you, for example, only want to use remote executors, you can set it to 0. And the same holds true for the remote executor setting. By default, it's unrestricted. So it's only restricted by the number of agents that are connected to Gradle Enterprise. If you know you don't have to use more than 10, for example, you could set it like this. And then last but not least, there's the requirements. So that allows you to put in any kind of string values that you then match against the agent's capabilities. And OS and JDK are automatically detected. You can add additional ones to the agents, as I will show later. A word about the Java runtime used on the agents. So for each test task, we detect the major version of the JDK that this test task would usually be executed with. So which JDK would be used to fork and run the tests on. And we're going to add that as an implicit agent requirement. So the agent does have to have the same major version of Java installed, so you can run the tests on that. Yeah, and only matching agents will thus be matched and are eligible then for test execution. You can, of course, have multiple JDKs installed on the agents, and different test tasks can use different JDKs, and those would all match then to those agents with those multiple JDKs. Yeah, now for some numbers. Benedict has shown like a few of those, not all of them. So the first one was just like for our demo project here, running it with a default Gradle configuration of Maxwell Forks 1. So just one local executor. And that took about 1 minute and 57 seconds, I think, or 54 seconds, something along those lines. And then Benedict increased the number of local executors to 2. And you can already see then there's a decrease in the build time and the test time by about 50%. So that cuts time in half. And the good news here is, as you add remote executors, you can achieve the same effect. So we went from 2 local executors here in our measurements to 4 executors in total. So that means 2 local ones and 2 remote ones. And again, the build time was cut in half. So that's a reduction by 50%. And we can continue that. If you double the number again, we go from 4 to 8 executors. We can reduce again the build time by 50%. And then you can continue that. So there's a dotted line here to the right? So you can cut it down further. Of course, at some point you have to decide, is it worth it? I mean, this could be, right now this is 30 seconds, right? But if you have a real build, this might be 30 minutes or something. And then even a reduction that seems like a small deal here could already be 10 or 15 minutes, and that might still be worth it to add additional remote executors to speed up that test execution. So bottom line, doubling the number of executors cuts build time in half, and that's great news. Now we can scale beyond just a local machine. Of course, there's some overhead that I'm not gonna neglect. So executing tests on agents has overhead compared to local execution. One thing I talked about already was the inputs. It means the test classes, the jars on the class path, any additional files that are required by the tests. They have to be transferred from the build to the agents, right? That's file transfer. And to mitigate that, agents cache and reuse previously received files, so they don't have to transfer them again the next time. And that caches on the local file system. The other direction, so any outputs that are produced by the tests, for example, the Jacoco coverage file or any custom reports, they have to be transferred back to the build. So those are usually smaller because they are not jar files of some artifacts, right? So the Jacoco exec file, for example, is pretty small. So that's pretty much usually not the big deal. And then, of course, there's some communication going on. So the build has to talk to Gradle Enterprise and the agents as well. And yeah, so that communication has some overhead. And the bottom line, the rule of thumb here is really the faster the network connection, the smaller the overhead. So this works best when both the builds and the agents have fast connections to the Gradle Enterprise server. There are a few prerequisites for using the test distribution plugin in your Gradle builds. So it requires Gradle 5.4 or above. And of course, it requires Gradle Enterprise. 20.2 will be the version that's released in April, so next month. Tests running on the JNet platform are supported. So we support JNet Jupyter, which is the new testing framework introduced with JNet 5, but also JNet 3 and JNet 4 tests. They are still supported, and you just have to add the JNet Vintage engine to your test runtime class path. And the same holds true for frameworks like Spock that technically basically have a JNet 4 runner that can execute these tests on JNet 4 and then by the Vintage engine also on the JNet platform. And in addition to that, any test framework that already has a JNet platform engine is supported by this approach. A direct consequence of using JNet platform is it requires Java 8. So we now require Java 8 test runtime for using test distribution. Again, a small reminder here, I'm talking about Gradle a lot here, but we will have Maven support, just not in the initial release. It will come in the next release then. Okay, next poll. We would like to know which test frameworks do you use? Let me send that to you. We have about 80%. Let's see, let's give it another few seconds.
We already have a lot of questions. I'm trying to answer them while you go through the slides, Mark. But I guess we will try to answer everything at the end of the presentation.
Yeah, we will have time at the end to go through the questions, hopefully. But yeah, sure. Any questions that we can already answer, we should. Okay, so this is the result of the poll. We have about 2/3 who use JNet 3 or JNet 4. We have about half who use JNet Jupyter. Cool, awesome. Okay, so I'm a bit biased, I have to say. Okay, Spock, we have 27% of people who use Spock, which is also supported. Then we have 17% for TestNG. The bad news here is TestNG will not be supported in the initial release. So there is a prototype JNet platform engine for TestNG. So I'm still hoping that will pick up, and then you will just be able to use that and then run TestNG tests on the JNet platform. And for the people who responded with other, please send us a question or a comment what that other is. We would be really interested in knowing that. All right, hide the results. Back to the presentation. All right. So I think a lot of questions that I've already seen by skimming through the list will be answered by this next section. So we now really focused on the developer point of view, like how do I change my build? What do I need to do there? And now we're going to take a different angle, and we're going to take a look at from the operations perspective. Like, how do these agents actually work? How to update them? What about scaling the agent pool? Does this work in Kubernetes? How can I monitor the agent pool? Is this even secure? How does this work? What about authentication, authorization, and so on? And we're going to try and answer all these questions. So running the distribution agent is actually pretty simple. Yeah, you just have to have some piece of infrastructure in your network that you can start it on. So you would give it a few parameters. You have to configure the server, the Gradle Enterprise server that you want to connect this to. And then for authentication, you will pass it in a registration key, which I will explain in a bit. And then you can also pass additional capabilities. So these capabilities are supposed to describe the environment the agent runs in, like it has Docker installed, for example, in this case, or Postgres as a database is available on this agent and can be used by tests. The agent itself comes in two flavors. So there will be a jar file and a Docker image. And yeah, it's basically a small application that runs on Java 11 or above. It requires a rather small amount of memory, so about 128 megabytes, and it runs on Windows, macOS, and Linux. So you can have different agents that run on each of these operating systems. And when it starts up, it detects the environment, so it detects the operating system it's running on. It detects the JDKs that are installed, so you can use all the JDKs that are available on that system, not just the one that runs the agent. So there's no direct correlation anyway. Yeah, and as I said, you can pass additional capabilities as command line parameters. And as far as updating is concerned, we don't expect that to be a big problem, because actually the Gradle plugin makes sure it's compatible with the agent by first sending a communication library that contains the whole protocol that the agent and the build need to talk via the distribution server. So that means that, yeah, an agent will have not just support for one version of the Gradle plugin, but basically many of them, yeah, because this component is not baked into the agent. There are, of course, a few security considerations you should be aware of. Since test distribution allows remote code execution inside your infrastructure, yeah, we require that the users that call this are authorized. So not just for anyone who can just, remote code execution does not sound like a light thing to have. So we require people to be authorized Gradle Enterprise users. And this is basically comparable to how CI job works. So if you have a CI agent and you run tests on that CI agent, you basically have the same issue. Those tests, they can do anything that you can do from your test code. Any files you can read from that VM that runs the tests, you can also read from the distribution agent. Yeah? So in that sense, it's very similar to a CI agent, and the same security considerations apply. Let me show you a bit more details about how builds have to authenticate and authorize themselves. So for authentication, we require that builds authenticate themselves with Gradle Enterprise access keys. If you have used authenticated build scans before, you might already know these. So this is a user-specific access key that you can generate. There are two ways to do so. Either you go to the UI that you can see on the left in the Gradle Enterprise server, and then generate a key, and then copy it and store it in your local system. The other way is you run a specific Gradle or Maven task to provision such a key for you, which will open the browser and ask you for confirmation, and then store it locally on your machine so you can use it for subsequent builds. And this access key we will reuse basically as authentication mechanism also for distributed tests. And there are ways to inject that access key via an environment variable on CI, for example, into your builds. That's authentication, but that's not all. We also require authorization. That means that the user that is authorized using the access, authenticated using the access key, also has to have a specific Gradle Enterprise role, which is called distributed testing. And only users that have this role are allowed to run tests on the test distribution infrastructure. So that means you could also set this up in a way that you create a user for CI, give it an access key, and only give that user distributed testing privileges, this role in the Gradle Enterprise administration. So this can only be done by a Gradle Enterprise administrator, of course, right? And then in that way, you can really restrict who is allowed to use this feature. This was builds. Agents also have to authenticate. This UI looks a bit similar to the user access keys, but in contrast, this is not a user-specific key. This is a key that's configured by the Gradle Enterprise administrator. So they have to log in, go to this UI and click on generate, and they get this full key. And then this is the key they have to configure their agents with, that they can pass this key to the Gradle Enterprise server to make sure that only authenticated agents can connect and be used on this Gradle Enterprise server. And of course, you can have multiple registration keys at the same time. You can use that to replace a registration key. You could give each agent its own registration key. You can revoke keys here that are no longer valid. And yeah, that kind of wraps up agent authentication. You will also be able to monitor agents and builds. So the agent sends regular updates of what it's doing to Gradle Enterprise so that administrators can monitor and scale the system. The admin dashboard is currently in development, so I can't show you that yet. It will show the connected agents and their status, like are they idle, are they doing work, what are they working on. It will show you the connected builds and the number of agents they have requested, or the number of agents that have already been assigned. You will be able to see the build queue length over time. That will help you to make an informed decision whether you need to scale up or down the number of agents. All right, so let me sum that up. These are the key features of distributed testing in Gradle Enterprise. It uses single machine parallelism when no agents are available. So that means even if you don't get any remote agents assigned, your build should never be slower than if you just had used max parallel forks in Gradle. Enabling it is really simple. It requires a simple change to the build script. So there's no complicated setup. You don't have to, for the CI fan out, for example, this takes a lot of effort to set up and maintain. For this, it's really just a simple change to the build script. The test set is partitioned automatically for you, so you don't have to worry about that. And it works for local and CI builds. This is a major benefit. So you can now actually run local tests that run on different operating systems right from your development environment. No need to go through CI. The test reports and build scans, as we've seen, they show the results of all the tests. Yeah, if you have CI fan out, for example, you would get a build scan for each of these executions on each of these nodes, and there would be no aggregation. And the same is for test reports. You have to worry about that somehow to manually transfer these files back at the end. Of course, there are some tools that do that, but this is now really integrated. It's seamless. You don't have to do anything. And information about used agents is available in the build scan that will help you debug in case there's a failure that only happens on an agent. You will be able to see on which agent was this executed, and yeah, that will help you to find out and get to the root cause. Outputs are also transferred back to the build and merged automatically, so that, for example, for Jacoco, you will get an aggregated code coverage at the end without configuring anything. We handle that case transparently for you. Agents can be selected using requirements specified in the build, and specifically this means different test tasks, as we've seen, can have different requirements and run. Yeah, the selection happens basically in the build. You don't have to worry about configuring this test task to only run on this agent kind, on this other one, on this other agent type. This is all handled in the build. And last but not least, this all runs on premise on your own infrastructure. So that means both the agents run on your own infrastructure, the Gradle Enterprise server runs on premise, and your builds run on your developer machines or your CI agents. So everything is inside your network. You don't share any information you don't want. Yeah, so that brings us to our final poll for today. The question is, where do you see the most value in deploying distributed test execution in your environment? Let me open that. Yeah, now I should have it. So let's give it another few seconds. We're about 80% now. %, I think, doesn't go any further than that. 84%. Okay, close this and share the results. Okay, only 1% said I don't see any value. That's cool. I'm not sure. Well, okay, enough. Speeding up feedback cycles for local builds, only 18%. speeding up local and CI builds, so 57%. Cool. Making CI builds faster, mostly 15%. Cool. So I think that's really significant that also local builds can benefit from it. It's not just a CI thing, and yeah, it can really change your workflow also as a developer locally. All right, let's go back to the slides. There we are. So kind of to sum this up, if you have ever visited the Gradle.com website, you've probably come across this statement here, that build caching and build scans can give every developer back an hour a day. And I believe now that we add distributed testing to the mix, I think we can even change that. And I think we can say we can give every developer back 2 hours a day. And I think that would be a very motivational, inspiring goal to have, not only for me as a developer at Gradle, but for everyone really being excited about faster builds, faster feedback cycles, and increased productivity. Yeah, I hope some of you are asking yourself now, how much faster can I make the feedback cycle in my own build? And the question to that really is, well, there's no silver bullet. You just have to try it. You have to really try to get the most out of it. And for that, we will help you, right? You can request a free 30-day trial of Gradle Enterprise. And this is not some salesperson telling you what to do. This is really an onboarding with a Gradle domain expert. That means in case of test distribution, it's probably going to be Benedict or me, right? So we will really help you get the most out of this. And in this free 30-day trial, you can request on the Gradle website. Yeah, you can already let us know that you're interested in test distribution. So even though it's not yet released, we can note that down and get back to you. Or of course, there are other features in Gradle Enterprise. So if you're not already a customer, that might be interesting to also try build scans and build caching and see how far that can help you. Yes, and with that, I would like to open it for Q&A. I believe Benedict has already pre-scanned the question list a bit. And just a short note, in case we don't get to your question for some reason and you really want to know, please send us an email and we will follow up on that. Yeah. All right, Benedict, what's the first question?
There's like a ton of questions.
Okay.
So it looks like we got people excited, and there were also some people saying that they liked what they saw. Thank you for that. So there are some questions regarding Android. How does it work with Android? Can I use it in Android Studio? Maybe we go with that first and try to answer this whole topic.
Yeah, so Android, yeah, I mean, of course, if you just have regular unit tests, they will work. If you have any kind of Espresso UI tests that run on the device or simulator, we will not support that initially, right? There's already existing solutions out there that can run your tests on a farm of devices, so we're not yet competing with that.
Okay, so here's the question. Does it work on all JVM languages, Scala, Java, Kotlin, Groovy? Yes, as long as they use the standard test task and as long as they can execute tests on JUnit platform. Then a lot of people asked about additional infrastructure. They have integration tests where they need to spin up databases. How can that be handled in distributed testing?
Mm-hmm. Yeah, so basically what we showed was you can have these capabilities on the agents. You can, of course, set up the agent and install the database in addition to the agent or any kind of other thing. It also works, I think I saw that question, if you have some native dependencies that you need, you have to you can pre-install these there and yeah, just tag basically the agent using these capabilities and then express those as requirements in your build. And Gradle Enterprise will make sure that you only get assigned matching agents for that requirement. So let's make it concrete. If you have a database, you would say, I don't know, you need Postgres, and then you would have an agent that has that capability. The administrator who set up that agent has installed Postgres in addition to the agent and specified Postgres as a capability when starting the agent. And then in the build, you would specify that Postgres string as a requirement And then Gradle Enterprise would make sure you only get agents assigned that have a matching capability.
Okay, a question that goes kind of in the same direction is integration tests that need to start Dockers would work. Any example? So this depends a little bit on how you start your agents. If you use, for example, the Docker-based deliverable that Mark talked about, so starting the agent in Docker, you will have to make sure that the agent process inside the Docker container can actually start a new Docker container and figure out how the tests running inside the Docker container can connect to the other Docker container. So there are a few patterns how to do that. I recommend reading that up, for example, on the test containers website. But that really depends on how you set things up.
Yeah, I think that's the same problem if you run those Docker things on a CI agent that runs inside Docker, right? It's the same underlying problem.
Then there are a lot of questions regarding pricing and licenses. We are just engineers. We can't tell you anything about that. Just get in touch with our salespersons, and then they can figure out the details with you. There are also some questions regarding autoscaling. Does this connect to my Kubernetes cluster? Does it do the same thing as the Jenkins Kubernetes plugin?
Yeah, so we will provide an endpoint kind of where you can get the queue length, for example, maybe some other metrics that you can use to make scaling decisions. I cannot promise that it will be in the first initial version, but yeah, we're happy to have that conversation with you and then figure out exactly what you would need and then build that. Yeah, so it's not yet fully developed in terms of auto scaling. Has not been our top priority so far. But okay, we will provide a solution at some point.
More and more tests are coming in. Let me just have a look. Okay, autoscaling, we talked about that already. Okay, this is a tough one, I guess. I don't have an answer to this, but maybe we can try to figure it out together. How would this work where tests need native C++ libraries? So I guess...
Well, it depends if those are kind of static and can be pre-installed maybe, or are the same then and can kind of be detected. It depends on if these native libraries are built kind of in the build, I would say. So it's hard to tell. I mean, if they can be pre-installed, then it's a no-brainer. Then we can use the same capability requirement mechanism that we have in place. So we can put those native libraries on that agent and then use them. If it's something you build yourself in the build, so it keeps changing, you would need to declare that as an input. And yeah, so that would mean they would get transferred automatically. But then, of course, you have the problem that your build machine might not be running even on the same operating system as your native library. So yeah, I'm pretty sure we will be able to find a solution for that. Yeah, but we don't have a prepared example as of now.
Yeah. Somebody is asking about JVM versions in a situation where a test needs multiple different JVMs. So actually the agent, when it starts, it tries to figure out what Java version it is running on, and we have some convention for environment variables. And if you set those and let them point to an additional Java home, the agent will detect that as well. So for example, let's say the agent runs on Java 11, but you have Java 14, for example, you set an environment variable and the agent will automatically set the capability that it can also run tests with Java 14. Okay. Oh, this is one for you, Mark. What logic does it use to decide how to separate the JUnit suite into the different groups? And there were other classes about, other questions about the runtime of the tests not being equal as in our demo project. What do we say about that?
Yeah, we will have a solution for that. The project we've shown has just, test classes that all take the same time. That's not very realistic. Of course not. It was good for the demo. But it's something we have to take care of course. So we will record the execution time of test classes, and then we will use that information to partition the test set into sets that have approximately the same length in terms of execution time, and those will become the partitions. Yeah, that's what we're going to do.
Somebody asked, what prevents Gradle to use this technology beyond test tasks and move towards remote build execution? Well, that's a very broad topic. Actually, we talked about things like distributing a whole build, but there is a whole lot of problems. So we decided to focus on test execution at first, because this usually dominates build times. And so we are thinking about it, but there's nothing on our roadmap as of now to implement remote build execution. Okay. I think there are a lot of things that we already answered. Somebody asked, what about custom test frameworks that use tests that are implemented in XML? Again, if you can execute those tests on JUnit platform, so if your custom test framework has an engine for JUnit platform, then it would work on with test distribution.
Or is it has a JUnit runner as well? So everything that can run on JUnit 3 or JUnit 4 or JUnit 5, we can run. If you have, basically the requirement is you would be using the test task already, and those files, those XML files, would be kind of on the test runtime class path automatically. Maybe they are in source test resources, or if they're in some other location, they would have to be inputs of the test task, and then we would transfer them automatically to the agent and run them from there. So that should work out of the box.
Another question for you probably. How does this work with parameterized tests generating large set of test inputs?
So I'm assuming this question goes in the same direction of test classes having a very different runtime. So I could imagine this parameterized test class having lots of tests and taking a long time to run. And yeah, that we would detect in the same way. We would track the usual execution time for that parameterized test class, and then yeah, use that to make a partitioning decision on that. And then yeah, it should work out in the same way as I said before.
Somebody asking about transferring of inputs. What is the performance like on the first build, where many agents need to pull the inputs from the build machine? Mainly thinking about for local developer builds. So this depends on what has been run before. So usually you have this the static set of things that doesn't change very often, like your dependencies. So all the jars will likely be available on the agent already, and then only the changed classes and tests will be transferred. But if you have like a cold start, you start a new agent. This might take some time depending on how big your class path is and how many artifacts you have to transfer. But as I said during the demo, it will never be slower as running locally, because your local executors will already start working through the test petitions. And it might even be the case that all petitions are finished before the last agent becomes available. But that's also okay. Then it will be released right away. Okay. Somebody's asking, I saw JDK requirement mentioned somewhere, but I could not recall. Is Java 8 sufficient? So Java 8 is sufficient for the plugin. If you want to use it inside your Gradle build, you can, of course, execute tests within. No, you can only use Java 8 because you need to use JUnit platform, and that requires Java 8. So on the build side, Java 8 is a requirement. The agent runs on Java 11.
Yeah, for the test runtime, you can use any JDK starting with Java 8 because of that JUnit platform requirement. So, I mean, Gradle, I think, still supports Java 6 runtimes for test execution. So test distribution does not you have to have Java 8 at least.
Okay, here's a question about Jenkins, I guess. When running JUnit in CI, XML files are produced. These XML files provide information about the test, its status, runtime, etc., and are used by Jenkins plugins to publish a report of the tests. Will these XML files be transferred from the Gradle slaves back to the Jenkins slaves so that they're available for the Jenkins plugins to be used?
You want to take that one, or shall I?
No, go ahead.
Okay, so yeah, actually for Gradle, these XML files are actually produced on the build. So they will be produced on the build machine, on the Jenkins slave in that case, directly. If they were outputs that would be produced by the agent or by the test execution, they would be transferred back automatically. So if you, for example, have some custom reporting framework that kind of hooks into the runtime of your test execution, maybe as a Java agent or something, and produces some files, as long as you have those files declared as outputs, we would send them back. For the special case of these XML files, those are produced by Gradle, and yeah, they will be in the same location as always, and nothing will change.
Okay, I'm looking through the questions. I think we covered most of them, and there are no new questions coming in really. I guess we could close the webinar for now, and if you have any additional questions after the webinar, you can also tag us on Twitter.
Yeah, before we close it, I would like to ask you all to fill out the survey after the webinar to give us feedback. That would be really helpful for us. And yeah, as Benedict said, you can of course send us questions. I didn't put the Twitter handles on here, Benedict, sorry, but we have the email addresses at least. So yeah, please feel free to write us an email, ask us a question about this. And yeah, all that's left for me to really is to say thank you for being here, for being interested in test distribution. I hope you found this interesting. And of course, I hope to have a conversation about adding this to your build at some point in the future. So with that, Dennis, you want to say any final words?
No. Okay. Yeah. You basically already said everything. If you have any questions, feel free to send us your question to training@gradle.com, and we will make sure your questions will be answered by Mark and Benedict, because no one knows more about distributed testing at Gradle than those two.
All right.
Thanks, everyone.
Yeah, thanks, everyone.
Take care and stay home.
Day and so on. Goodbye.
Bye-bye.